Today we're going to see the topic distributed computing. Before getting to the cloud computing, everyone should aware what is the concept and operation of distributed computing. Let me see one by one the basics of distributed computing. Let me start with a real-time example. Imagine you are a teacher who wants to organize a big school event. You need help with tasks like setting up chairs, decorations, and equipment, but you don't want to do it all by yourself. You could ask your students for help, but it would take a long time if everyone worked on each task separately. So this is where distributed computing comes in. Instead of having each student to work on every task, you can divide the task into smaller parts and assign them to different groups of students. For example, one group could set up the chairs, another could decorate the stage, and the third could set up the sound system. Each group works independently on their task, but they are connected through a network. Teacher and work together towards a common goal to make the event a grand success. By dividing the task into smaller parts and having different groups work on them simultaneously, you can improve the performance, scalability, and reliability of the event. For example, if one group is struggling with their task, the others can step in and help. If one group finishes early, they can help the others with their task. And if one group has a problem, it won't affect the other groups as much. So this is similar to how distributed computing works. Instead of having one computer do all the work, you divide the task into smaller parts and have multiple computers work on them simultaneously. Each computer works independently on its part of the problem, but they are connected through a network and work together towards a common goal, solving the problem or completing the task. So that's where the distributed computing arises. The next, we see the types of distributed computing models. And the first one is the client server model. In this model, a central server provides a service to one or more clients. For example, think of a restaurant where a waiter, going to act as a server, takes order from customers. The customers will be in clients and sends them to the kitchen for preparation. The kitchen processes the orders and sends them back to the waiter who serves them to the customers. And the next one is peer-to-peer model. In this model, all computers in the system act as both clients and servers, and they can request and provide services to each other. An example of peer-to-peer is a study group where each member can ask questions and provide answers to other members. Everyone in the group contributes and benefits from the collective knowledge. And the third one is the grid computing. So here it is when a large number of computers works together to solve a complex problem. Each computer works on a specific part of the problem and the results are combined to give the final solution. For example, think of a team of scientists who are working on a project to model the effects of climate change. Each scientist has a specific task, such as analyzing data from a particular region or simulating weather patterns. The results are combined to give a comprehensive view of the impact of climate change. So this is another example for the grid computing. And the last one is the cloud computing. In cloud computing, a large number of virtualized resources are provided as a service over the internet. These resources can be used to perform a variety of tasks, including distributed computing. For example, imagine a company that needs to store large amounts of data, process it, and make it available to its employees around the world. They can use cloud computing to store the data, process it, and make it accessible to their employees from anywhere in the world. The next we'll see what are the applications of distributed computing. So here majorly scientific research financial modeling, and large-scale data processing are the main applications of distributed computing. Let me go with an example. Imagine you are a scientist trying to study the behavior of a complex system like the weather or the human brain. You have a lot of data to analyze, but too much for one computer to handle. So that's why distributed computing comes in. Similarly, financial analysts and economists often use distributed computing to model complex financial scenarios. By dividing the calculation into smaller parts and assigning them to different computers, they can analyze large amounts of data and simulate various outcomes. This helps them make more accurate predictions about the financial markets and make better investment decisions. And for the third example, we can go with processing and application of distributed computing. With the rise of the internet and social media, there is more data than ever before. So companies and organizations use distributed computing to process and analyze this data, which can be used for things like improving customer experience, detecting fraud, or making marketing decisions. And distributed computing has become increasingly popular with the rise of cloud computing and the use of clusters of inexpensive computers. Instead of relying on one expensive computer, you can use a network of cheaper computers to get the job done faster and more efficiently. Next, we'll see an advantages and disadvantages of distributed computing. We'll go with an merits with an example. Imagine you are a business owner who needs to process a large amount of customers' data. As your business grows, you need more computing power to handle the increased workload. With the distributed computing, you can easily scale your system to meet the demands of your growing business. By adding more computers to the network, you can distribute the workload and process more data in less time. The another benefit of distributed computing is fault tolerance. In a centralized system, if the server goes down, the entire system goes down with it. But with the distributed computing, if one computer fails, the other computers can continue to work, ensuring that the system stays up and running. The ability to harness ideal resources is another advantage of distributed computing. Many computers are only used for a fraction of their capacity, and distributed computing allows you to tap into this unused computing power. By harnessing ideal resources, you can save money on expensive hardware upgrades and improve the efficiency of your system. However, there are along some downsides of distributed computing. So demerits, network latency or the delay in transferring the data over a network can slow down the performance of a distributed system. This can be a problem for real-time applications such as video streaming or online gaming. Then communication overhead is another issue with the distributed computing. With multiple computers communicating with each other, there is an increased risk of errors and delays. This can lead to slower performance and decreased efficiency. And the last one, specialized programming languages and the frameworks are often required for distributed computing. This can make it more difficult and time-consuming for developers to create and maintain distributed systems. So next we'll see on common technologies and the protocols which are used in distributed computing. Imagine you are a data scientist who needs to analyze a large data set. Using a traditional file system, it can be difficult to manage and access such a large amount of data. This is where a distributed file system like Hadoop, HDFS can come in handy. With HDFS, you can split your data into smaller pieces and store them across multiple computers. This makes it easier to manage and analyze your data, as each computer can work on a smaller piece of the overall dataset. For distributed data storage system, Cassandra and MongoDB are two popular options. This system allows you to store and retrieve a large amount of data across multiple computers. This makes it easier to scale your data storage as your needs grow, while also providing the fault tolerance and high availability. If you need to handle the large amounts of data in real time, a distributed messaging system like Apache can be helpful. It allows you to stream data in real time across multiple computers, making it ideal for use cases like financial trading or real-time analytics. For scheduling and coordinating the task across the distributed systems, tools like Apache, Mesos, and Kubernetes can be useful. These systems allow you to manage and allocate the resources across multiple computers, ensuring that tasks are completed efficiently and effectively. Finally, for distributed computing frameworks, Apache Spark and Hadoop MapReduce are two popular options. These frameworks allow you to process large amounts of data in parallel across multiple computers, making it easier to scale your data processing as your needs grow. So these are the basic concepts which comes under the distributed computing.